Using analytical patterns is going to save you an unbelievable amount of time as a data engineer because let's face it, not all data engineering pipelines are built differently. There's just a couple different patterns that you want to look into, and if you can see these higher level patterns, then you'll know exactly what type of pipeline to implement. In this 2-hour course, we're going to be covering two of the very important design patterns. One is growth accounting, which is how Facebook tracks the inflows and outflows of active and inactive users. This can also be used for any other state change transition tracking. It is closely related to the cumulative table design concepts in weeks 1 and weeks 2 that we used for dimensional and fact data modeling. I'm really excited to show you that. And then we'll also be covering the survivor analysis pattern, which is looking at, of all the users who signed up today, what percent of them are still active in 30 days, 60 days, 90 days. It's kind of like that retention number that is super important for the success and growth of companies. And if you can learn how to apply these analytical patterns, you will become a much more powerful data engineer. I hope you enjoy the course. And if you want to learn how to apply these patterns in the cloud, you should check out the Data Expert Academy in the link in the description below, and you can get 20% off. What are we talking about today? Repeatable analyses are your best friend. And why are they your best friend? One of the big reasons they're your best friend is because they allow you to think at a higher level. Instead of having to think about like the group by and the select and that level of analysis, you can think one layer above that, which is like kind of a more abstract layer, and then recognizing that the SQL will write itself once you can recognize that higher level abstraction. And so if you have that higher level abstraction, great, that's great, and you'll be able to do some really good stuff with that. And that's one of the big things as you kind of grow in your career as a data professional. You should be looking for these like higher level abstractions. That's why, like, when you start out as a data engineer, you work on like one pipeline, and then usually it grows to like a family of pipelines, and then it's like a warehouse of pipelines, and then it's like the entire data warehouse. And like you just keep building like a bigger and bigger and bigger scope. And so one of the things that you need to be able to do in order to get a bigger scope and get that step up is you need to be thinking about things beyond the language that it's written in and beyond like the ones and zeros that it's written in. Because if you think about it from another layer, right, of why repeatable analyses are your best friend, is you can think of it as kind of like an extension of SQL in some ways. Because on one side, SQL or SQL, I mean, I'm not going to call it SQL. So SQL is going to be like already an abstraction, because SQL ends up just giving instructions to some sort of engine, which usually then processes it with like either usually like C++ or Java or some other kind of more high performance language, and then it will crunch the data down, and then it will give you your data result back. And so that's also an abstraction. So if that's an abstraction and we're working with SQL, like why do we have to be married to that layer? Why is that the layer that is the layer that matters the most? Like, is there such things as layers above? And obviously there are layers above that you could think about that, but like a lot of these layers above are ones that I think are actually not good for your career. For example, like low code or no code tooling, where you just don't even write code at all and you just drag and drop boxes around. And that stuff is useful, but not generally speaking for technical people. That stuff is not as useful. And we're going to go more into details around that on like how having overly abstract stuff can actually be a detriment in some cases as well. But anyways, we're going to be talking a lot about some common analytical patterns today. One of the big ones we're going to talk about today is state change tracking. So state change tracking is essentially like, one of the things I like about state change tracking is it's actually really closely connected with SCD. You can almost think of it as like the opposite of SCD in some regards, because SCD has records for every different value of a dimension. But imagine if you had a table that instead of keeping all the values of the dimensions, it keeps track of every time that dimension changes. And you just have like the change log. of like, oh, it changed on this day, it changed on this day, it changed on this day. And that's kind of what state change tracking is all about like, okay, like where did they go? Like where did they go? How did they change? Did they come back? Kind of stuff like that. We're also going to be talking about survivorship analysis, which I needed to put on this slide. And the last thing we're going to be talking about is window-based analysis. And we're going to be doing all three of these in the lab today, and they should be a pretty good time. The queries for that stuff they aren't too crazy. And keeping in mind that some of these are really closely linked with the concept of cumulation. You have that cumulative table design that we talked about in week 1. And some of these are actually based on top of cumulative table design, and they don't work very well without cumulative table design. So keeping that in mind as we kind of go through this presentation, that what I'm trying to do is teach y'all the kind of layering of all this stuff. And hopefully this will give you some powerful tools in your tool belt for when you are building out your pipelines. So yeah, let's dig into this stuff. Repeatable analyses, right? In the last slide, I was talking about how it reduces your cognitive load because you don't have to think about things in SQL. You can think about things at kind of like bigger picture layers, right? Because imagine like if you're the CEO of a company and you had to think about every single line of code. Like imagine one of my beautiful examples I like to give in this case is, so at one point in my career, I wrote a dashboard for Mark Zuckerberg, and he liked my dashboard a lot. But like, had I been like, nah, Zuck, like, you gotta write the SQL. And he's not gonna write the SQL because that's not his abstraction. He's like, nah, dude, that's too much of a cognitive load. I don't need to care about the column names. I don't need to care about any of that. I just want the picture. And so that's one of the things that I hope that we as data professionals can get better at, is understanding the right layer of abstraction. Because a lot of the times I think as data engineers, we're like, we live, breathe, and die by SQL. And if you take our SQL away, like some of us would feel like we are a knight without a sword, or we're a knight without our armor, or we are, we aren't even bringing a weapon to the gunfight anymore if you take our SQL away. And so that's something I want to change. And that's one of the goals of this presentation, is for a couple of reasons. Because one, like in the future, the abstraction is going to change. LLMs are going to change things. SQL is going to be different, or how we create SQL is going to be different. So really the more important thing is having these higher level patterns and understanding how to apply these higher level patterns. And then it's going to be in some ways, it's going to be a very exciting time. I know that in some regards, some data engineers have some fear about this, where they're like, oh, wow, if ChatGPT can just write SQL, like, am I deprecated? Am I just going to be laid off? Am I not going to be around anymore? And I don't believe that. I believe that if you have a firmer grasp on these higher level analytical patterns, then you can be that ChatGPT using engineer who can write pipelines incredibly quickly, and your value to the company will be just astronomically higher. And that's why the second bullet here is all about streamlining your impact. Because if you had to think about like, okay, if I needed to like go to the store and I want to make a cake, and every single time I want to make a cake, I like go to the store, get the or I get the flour, get the egg, get the sugar, get all like the raw materials, and like, stir it up and make the cake. Like, that's good, and that kind of makes you a baker. But that's not necessarily the best way to go, because sometimes maybe you're strapped on time. Maybe the stakeholders are like, can you just pull this cake for me real quick? And you're like, dude, like cake making takes time, and like if you ask for it to be pulled real quick, I'm gonna burn it or whatever. And that's where these patterns can help you do things where, instead of maybe making everything from scratch, you buy some of the pieces pre-made, and then all you do is put the frosting on the top of it, and then the rest of it's pre-made and ready to go. So that stuff's pretty cool. That's one of my favorite parts about repeatable analyses, is once you recognize the higher level picture, the pipeline writes itself. It really does. Like you have to be careful around the edges and like being careful around like cumulative table design and like a lot of the gotchas there for some of these patterns. But if you got those down, then I wouldn't worry too much about it because you know the higher level pattern and what the pattern looks like. And yeah, you'll be good from there. So remember this, repeatable analyses are your friend. They allow you to play with bigger Legos. You don't have to play with like the little tiny two-piece Legos. You can play with like the bigger ones, and then they can kind of stack together, and you can build a tower way faster. So that's my main goal here about this is recognize that repeatable analyses are very powerful. So when I was making this slide, I was trying to figure out all the high level analyses that I've ever done in my career, and it's wild because I really think that there's only three buckets here. There might be more, like if you are kind of pushing the envelope and you're not in the data engineering realm and you're more in the data science realm and stuff like that, there might be some other analytical patterns that exist. But for the most part, I've found there to be three. You have aggregation based patterns, accumulation based patterns, and window based patterns. And if you can master these three patterns, you are going to be a master of analytics. And like 95% plus of all the pipelines that I've written in my career in big tech, they use these three patterns. So if you can figure this stuff out, that's going to be great. Like some regards, you could say that there's another one called like an enrichment pattern where you like do a join and bring in other columns. But my whole point about this lecture is that we are already at the master data layer where we have all the columns that we need. So enrichment does not take place in this realm because we already have all the columns that we need. So that's going to be the one that could potentially, you could argue, could also be in this list. So let's kind of go over each one and go over the depth of each one because there's a lot. There's a lot in each one of these buckets. So I really hope to illustrate to y'all how to really build on these aggregation-based patterns. So aggregation-based patterns are probably the simplest patterns. So when you're building out a pipeline and you do an aggregation, there's a certain keyword, a SQL keyword that should be screaming at you. When you say aggregation, there's one keyword that should come up, and that's group by. So you have group by. Aggregations are all about grouping by different things and counting things based on different dimensions. I remember when I was working at Facebook, they back in the day, like when I was there 2016, one of the tenets of the company was move fast and break things, which for me I loved. I found that to be so amazing. And then after like 6 months into working there, they were like, no more move fast and break things. We're done. And then they tried to change it. And then for like the software engineers, they changed it to move fast and build things. And then for the analytics people, they changed it to move fast and count things. And so like I don't know, like I was always sad about that. But my main point with that whole story is counting is a very important part of analytics. And it doesn't get enough credit. It honestly does not get enough credit because it's not sexy, it's not fancy, it's like I don't know, it's like the meat and potatoes of analytics. Like, saying, oh, we have 7 million users in India and we have 5 million users in the US or da 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 da. Like, and it's just like we have this stuff. Or like a line chart of growth and being able to see like, oh, this is our line chart. And you can do really cool stuff with line charts even as well, and you can be able to combine them and look at all sorts of different things. And so when you're doing an aggregation and an aggregation-based analysis, you're gonna have some aggregation functions, like usually like sum or average or count. Usually it's those. That's usually it. Sum, average, count. That's about it. Like that's what you're gonna be using for this. Like maybe more funky stuff like array ag and other things, but we're already at the analytics phase, so at this point you're going to mostly be summing, averaging, and counting things. That's like In our last class, I guess there was one more. There was the percentile. Percentile can be an interesting one, but percentile and average are like the same thing, right? Percentile is just or average is just a specific case of percentile, where average is just 50th percentile. So those two functions are technically the same thing. They just have like it's just like where in the distribution you pick, and so I don't know. It's some pretty good stuff. So but I get no, that's median. My bad. Median and percentile are the same. Those are the same, not average. Average is different. Average is because average could be skewed. Made a mistake there, but median is another one that you could potentially use in these cases. But one of the main things I'm trying to say here with aggregation based analyses is you're going to group on things and you're going to count things and you're usually going to bring in some dimensions. In this case, you might have like country or gender or device or I don't know, all sorts of different dimensions. And those dimensions can be really powerful to see what's going on. And for example, another thing I worked on at Facebook was this thing called the root cause analysis framework, where what it did was you could plug in any metric and then it would explain the movement of that metric. So say, for example, you had a week over week change and the week over week change of the metric was like plus 1,000,000. And then what it would do is it would give you the dimensional breakdown of that of like, oh, it's plus 1,000,000, but it's actually like plus 1.5 million in the US and minus 500K in India. And it will give you the actual, because the total grand total of a metric is positive or like it moves in one direction, doesn't mean that all the dimensional cuts within it are moving in that same direction. It's just that like in total, they all add up to that together. So one of the things that you can do with root cause analysis is if you see kind of a certain shift in a metric, then you can start bringing in other dimensions to see like, oh, is it because of gender? Is it because of country? Is it because of device operating system? Is it because of height or whatever your or age? Or there's all sorts of different dimensions that you could bring in to try to diagnose a shift in a metric. And that is one of the things that I think is one of the most important parts of being a data analyst, is being able to do that, is being able to like say like, okay, we have a line chart here, we see a dip, and the reason for that dip is X. An example I have is like, I remember when I was early in my career at Facebook, I was working on growth, and then there was a massive dip in growth, and they did the root cause analysis, and it was because Ethiopia shut off the internet, and so there was like no users in Ethiopia. So, and since there's no users in Ethiopia, that's a kind of a big problem. And so that's kind of the idea behind root cause analysis, is you really are trying to do kind of the slice and dice and the storytelling that gives a better picture besides like number go down sad. It's not that. It's number go down sad and we have these people to blame, or we have this product to blame, and like it makes it so you can point a finger when number go down, and so that you can actually blame your sadness on something, not just like, oh no, the number's down and I'm like, I'm freaking out, man. And so that's like one of the things that I think is very important when doing root cause analysis, is it gives you a lot firmer picture of what's going on with your metrics. So yeah, let's go on to the next slide. Okay, so remember what I was saying before. You have it's the most common type of analysis, like just straight up, it's the most common by far. It's at least half, maybe more of your analyses are going to be aggregation based analyses. So, and keeping in mind that those other two, the accumulation and window based analyses that I talked about in the earlier slides, they can then be moved. They can also have an aggregation based analysis on top of their own outputs. So that's where this is always just really, really powerful. And you know, group by, always have group by. So another big thing about this is you have trends that we were talking about, and then we have root cause analysis, which I was talking about in the last slide about like why things are happening. You can also have composition of like to know, okay, we have this many users in the US, we have this many users in China, or whatever. One of the things that I think is important about doing these analyses is they should be at when you're doing these aggregations, you shouldn't be going back to the fact data, even though there's probably a strong urge to go to the fact data. And because with fact data, like the problem with it is fact data should be aggregated along the dimensional line. Usually that's going to be user. It might be like listing ID or device ID or like group ID or some other entity dimension, but usually it's going to be user ID. And you want to have things already aggregated up because like the problem is like if you're going to do fact data and you're going to like join in all these like spicy dimensions as well to bring in, and then you're going to like bring in all these spicy dimensions and then aggregate your fact data, like that's just going to be gnarly because those dimensions won't be like one-to-one. Because if you're at the daily grain where you have like one row per user per day and then one row per user per day per metric, then when you do the join, it's the same number of rows, right? Because you just do a join and it's just like one-to-one and the matching is done, and then the volume is better, shuffles a lot better, and you're going to get way better performance if you have that kind of daily aggregation staging layer than if you do your aggregations at the fact layer. So always kind of think about that when you're doing this aggregation based analyses, is that you should have that other layer called like your daily data, or like your daily aggregate data that is aggregated along like a user ID. For a couple reasons. One of the other big reasons is that if you have that data is also very powerful for experimentation. Because then if you have, okay, all the data along the user ID, then you can put users in group A or group B or group C or whatever test and control that you want. And then it's very easy to then like add that dimension into your metrics. And that will show you, people in group C versus people in group B, there's a lift or a drop in the metric. And that's where like you get, it's like a double whammy, right? You get your experimentation metrics essentially for free, but you also get more efficient aggregation metrics as well for like slice and dice and moving things around. So that's a big thing. I needed to add a chart here for composition, but I think y'all know what composition is. I didn't need to put like an ugly ass pie chart in this presentation for y'all to get what I'm trying to say. So anyways, that's kind of the idea behind aggregation-based analyses. So what about some gotchas here? There's a couple gotchas that I think are important. Is when you're doing aggregation-based analyses, you're bringing in all of these dimensions, you want to be careful to not bring in too many dimensions because we have that daily data where it's like you have all my metrics, but what if instead of that, what I did instead was I brought in these dimensions. I brought in dog name, I brought in city, I brought in height, I brought in profession, I brought in like follower count, and then I just brought in like a couple different other dimensions that could be but I brought in all of those at the same time. And then the problem is like once you get a certain number of dimensions in your aggregation-based analysis, you just are back to the daily data because enough dimensions together you will go back to uniquely identifying a person essentially. And so that's where you want to be careful because if you have like one person or a small group of people in your like aggregation, then I don't know, does that matter? It's like in those situations where it's like, this grain of data had a 50% growth, but it went from 4 to 6, and it's like, woo, congratulations, yay, right? But it's like that's where when you're doing these aggregation-based analyses, you really do want to be carefully considering like the grain that you're working with. That's where there's some grains that are beautiful, like. I really like gender is a great grain because it's like it's going to cut it in 2, 3, 4. I don't know, like that many. It's not very many. And then also country is a good one. Country is an iffy one sometimes because like some countries are really tiny and there might be like for me I know that there's one person in Kyrgyzstan who follows me on Substack. And so if that person leaves, then I'll see a 100% drop in my metric and I'll be sad. But it's like, you got to be thinking about that as well. That's why, like, when you are doing this stuff and you're looking at especially percentage-based metrics, make sure you're looking at the actual counts as well, because it's like, oh, it's a 100% drop, but it goes from 1 to 0, and it's like, okay, that's not a big deal then. It's like one person. So that's a big one. Another big thing to look at here is when you're doing a long time frame. This is something I talked about a bit in week 2 when I was talking about like that long-term analysis framework I built at Facebook. Is you don't want to have too many cuts in your data when you're looking at a long time frame, because time is also a dimension that's kind of like country, where it's like kind of high cardinality, because if you are looking at that kind of stuff, then you want to be careful. And that's where you can kind of, if you want to do these analyses on a longer time frame, you can lower the cardinality of it and just don't look at it per day, but maybe look at it per week or per month or even per year, where then you like aggregate all the data across an entire year, as opposed to like still holding on to the daily grain. Because if you hold on to the daily grain and you're doing some sort of long-term analysis, like, you're just going to get a lot of rows of data, especially if you then choose other dimensions that also are high cardinality. Then you're going to get really a lot of rows. Even like just country and day is going to give you a lot, because if you think about it, like, oh, if you have 90 days and then you have country, then that's like, okay, that's going to be 90 times 200. That's not too bad, 1,800 rows for 90 days, right? But then if you add any other higher cardinality dimensions, good luck, right? Because then you have 1,800 times whatever other dimensions you also want to cut by. So that's what I'm saying, is that like the combination stuff really does make a big difference. So yeah, aggregation-based analysis, pretty good, pretty straightforward. I hope that stuff is important. And my whole point here is just trying to give you a perspective at a kind of a higher level of not like, oh, I need to solve this specific group by query, because I'm sure most of y'all in this call have done this exact set of stuff before, but haven't maybe thought about things at a more abstract layer like what I'm talking about now. Okay. So now we're going to switch gears here to accumulation-based patterns. For accumulation-based patterns, we're going to talk about 2 big ones. We're going to talk about state transition tracking, and then we're also going to talk about retention and J-curves. It's called retention, it's called J-curves, it's also called survivorship analysis. There's a bunch of different things. I'm going to have a table that shows all the different like things that you can do with that one. And then state transition tracking has some other names as well. So yeah, let's kind of dive into this. So these patterns are going to all be based on that cumulative table design that we worked on in week 1. And so if you have a firm grasp of that fundamental, these analytical patterns can be built on top. And I think you'll be very happy to see how this works. Okay, so for accumulation-based patterns, one of the big things that is different about them versus aggregation-based patterns is that they care a lot about the relationship between today and yesterday, and the shift of state between today and yesterday. And so those things can make a big difference, where it's like, okay, are you active today versus yesterday or not? And kind of how you shift and change and do that kind of like slowly dimension kind of as you walk through your life. And so that can be like, that's like probably the biggest thing that you are going to be looking at when like, or the biggest difference between like a simple aggregation based pattern versus accumulation based pattern. And remember, full outer join here, your best friend. It's going to be so good, because the big reason why you need full outer join for these patterns is because you need to keep track of when there isn't data. That's the other big thing that's different between this pattern and the aggregation-based pattern, is that no data is data. And like, it's like that's one of the things that like aggregation-based patterns don't care about. Like, if there's no data, you just ignore it and it doesn't matter. But in accumulation-based patterns, no data is data, because the fact that they didn't do something means that we want to keep track of that. The non-existence of data is something else that we want to keep track of. So that's a big thing as we kind of go through this. Like I think that will make more sense as this presentation goes on. So I was talking in the last slide about the survival analysis and state change tracking. So those are kind of the two big patterns that we're going to be covering in the lab today. We're going to talk about growth accounting real quick. This is a special version of the state transition tracking. And this is where the accumulation part of it will make more sense. So you have, in this case, there's 5 states a user can be in. So the first state is new, which means that yesterday they didn't exist, and then now today they are active, which they have to be because they signed up today. So that's going to be the first state. Then you have retained, means that they were active yesterday, they're active today. Pretty straightforward. They just stuck around. Churn is active yesterday, inactive today, so they like left. Resurrected is like the opposite of churn, where they were inactive yesterday and active today. And then stale are the people who like they didn't come back. They were not active yesterday and they're not active today, so they churned out, or they are stale because they don't care. In some in some patterns, you have a sixth state of like deleted or deactivated for users who are like active or inactive today, and then they don't exist, or they were active or inactive yesterday and then they don't exist today because they like disappeared, because like you have to filter them out. Because sometimes in these growth accounting patterns, there's like policies that make it so you can't just hold on to everyone's data all the time, because like that's like a privacy concern. So in those cases, like sometimes you can have a sixth state here, which is deleted. Facebook just anonymized everything though, so that we could just hold on to everything forever. So, and if you hold on to everything forever, then there actually isn't a deleted state. You just are stale. You just stay stale forever. And so, yeah, that is, I've noticed that that's one of the things that I've noticed that has been a difference between this pattern, or that like how this pattern is different depending on how you apply it. So one of the things I want to talk about here though is this pattern is actually incredibly powerful. So let's kind of go over like a chart with this though, because I think that will help make this pop. So this is kind of like the idea behind how these charts work, right? So this is like MAU, monthly active users growth accounting. And in this case, you'll see you have churned, or all the people who are leaving, those big red bars. And then you have new, right? These are the new users. And then you have the resurrected users. And so in this case, growth, you can think of growth as new plus resurrected minus churn, and that will give you the growth rate of your business, or the growth rate of how many people are coming back, how many people or how many incremental people you're getting, because it's like the people who are coming in and the people who are leaving. So you have like the incoming and the outgoing. So one of the big things that I want to emphasize here is this is not just specific to growth. You can do this in all sorts of different areas as well, because you could think of like churn, resurrected, new. These are just different states that an entity can be labeled in. So I want to talk about just a couple different other times. So I've done growth accounting at Facebook. I've used this exact pattern at Facebook to track like notifications growth and stuff like that, to see how users are using different notifications and interacting with different notifications. But like, and kind of the poster child version of this pattern. But I've also used this pattern for more abstract or more different things that, like, for example, also at Facebook, when I was working there, I worked on tracking fake accounts. So in that case, you have like a new fake account, which was an account that had never been labeled fake before, and then they were labeled fake for the first time. And then you have a resurrected. Instead of resurrected, I called it a reclassified fake account. And that's where you have a fake account that like was labeled fake, and then they were unlabeled fake because they passed a challenge where they like uploaded an ID or something like that. They actually were like, see, I'm a real person. and then they were classified fake again. So that's like fake reclassified. And then you also have like the churn state, which is declassified. And in this case, churn is like, I mean, that could be a good thing actually in Facebook. That means that there's like fake accounts that are leaving, right? And so in that case, you can see for fake accounts, you have the exact same set of states as you do for growth, but it's just fake, not fake, and like the history of like, were they ever classified that way ever? So that's another great example of like a use case for where you can use this state transition tracking. So I want to go over some more that I use this analytical pattern. So at Netflix, I had another kind of classification algorithm, because you can think of like the fake accounts, right? That's an ML algorithm. It's a classifier, right, where it labels things fake, not fake, done, right? And then at Netflix, there was another machine learning algorithm I worked with that was labeling applications in the Netflix's microservice architecture. It labeled them as risky or not risky, or like too risky, and it was like a bunch of different states like that, where it was like this is like critically risky versus not critically risky. And then we wanted to track the flow of that as well, because one of the things that these types of patterns gives you is it gives you very good monitoring. You can monitor the health of your machine learning models, because when you are tracking stuff this closely, if like the fake account model at Facebook, like say they push a change and then it says like, oh, look at that, like all these new accounts are getting all these accounts are getting like reclassified now, or there's new accounts, or all these accounts are getting declassified, and that's not what we expected. Like this is a very, very powerful way to model the health of your machine learning models. So, and I had one more time that I used this pattern. This pattern has been very, very, very important in my career. Is at Airbnb, I worked on another model that was for hosts, because I don't know if y'all have ever been on Airbnb and ever had the experience where a host cancels on you, and like you fly to Europe and then the host is like, sorry, bro, we can't host you actually, and they cancel last minute. And that's actually one of the most painful things on Airbnb to happen. And like Airbnb is really trying to prevent that. So, you know, you can have ML that classifies hosts based on the probability that they're going to do that. And so that was another one that we did the same tracking of, like, it was like essentially it was labeling hosts as risky or not risky, and then kind of seeing the health of those and trying to see like, okay, what are we doing and how are we, because this is good for two things. Because on one level, it's like you can look at these charts to track the health of the model, but you can also look at these charts to track the effectiveness of whatever you're doing. Like, for example, like on Airbnb, it's like, are our higher level goals of like educating hosts and teaching hosts, are those things having an impact on host behavior so that we have fewer risky hosts? And so you have that kind of like higher level strategic thing that you can measure as well with this pattern. So I know I just hammered home that this pattern is really important, but like I've seen this pattern be very effective like everywhere I've worked in big tech. And so I generally think that this pattern is a very good pattern for ML ops. And like especially if you have a machine learning model that is a classifier. So if you have a classifier machine learning model, that's great. And this is where you can use this a lot. And that is where, yeah, so that's growth accounting or state transition accounting. I love this chart, and we're going to talk about survivorship analysis and bias. So this chart here is in World War II, there was fighter pilots would go and fight, and then they would fight, and then they would fly home, and then they would look at the planes, and then they're like, wow, we need to fix the plane. And initially, people were like, okay, and you see this chart, all the red dots are the damage, or like where it got shot and like the plane experienced damage. And people were like, wow, we need to bolster up. We need to make it so that the areas with all the shots are stronger so that they aren't shot. But then a really smart man was like, but wait a minute. But those are the planes that survived. So actually, the areas on the plane that need to be bolstered are the places with no bullet holes. And that will increase our chances of survival because that will bolster the areas that can't take a hit. And so in this case, you see the areas on the plane here, like kind of that midsection of the wing is where there's like no shots. That's really where they need a bolster because if a plane takes damage there, they don't come back. And so there's actually it's interesting how survivorship bias can impact you. But in this case, it makes sense. It makes a lot of sense that that's where you would want to go if you wanted to make your planes more effective. And like that's one of the things that I found interesting about a lot of different things like in my career and in other places, right? Where it's like I think like in content creation, that's a big one where it's like people like they like content creators like they will go on their journey and then like they get big and then they like they're like wow just do what I did and you'll be successful. And then a lot of people I think have a lot of false hope sometimes because they see the only people they see are the stars. They only see the people who won because you don't really necessarily see the people who tried and failed because they are kind of more invisible. And so you want to be careful. Survivorship bias can really have a gnarly impact on your view of the world and view on like what's considered fair or what's considered normal or all those kind of things. And that was a massive tangent for this presentation, but my whole point with this is survivorship and like how long things survive is another important measurement that we need to have in our analytical patterns. So let's talk a little bit deeper about this. Okay, so if you think about retention in some respects is just surviving. So you can see how there's essentially three ways that things can go. And you see at the top here how everything starts at 100% because there's the fundamental component of this analysis is what's considered a cohort or a reference date. So it's a date that like everyone is on the same page. A lot of times for growth, that's like the sign up date for a user. And then as time progresses, the state will change because some users will stick around and some users are going to leave. And so generally speaking, if you have an app that has that gray line, your app is kind of doomed because it's like as you get new users, like over time, they're just going to go away forever. And you don't have that kind of like stickiness that an app needs to like survive. You need that like crowd of people that just keeps coming back and keeps coming back and keeps coming back. So that's where like if you have either a green line or an orange line, those are going to be the cases where you have found a successful app because there's a certain percentage of users that are sticking around for the long term, especially that green line where like people come back and then like there's a bump in retention over time where people actually come back and they are more engaged than they were on the day they signed up. And that can be a very powerful thing to see. So J-curves, and the reason why they're called J-curves is if you kind of like, imagine if you flipped your laptop on its side, you would see there's like a little J that you can kind of see there. That's why it's called J-curves. So what are kind of some applications of J-curves maybe beyond growth, right? It's obviously like, I don't just like to talk about growth analytics because there's so many other areas where you can do J-curve analysis as well. So essentially J-curve analysis has 3 points. You have the curve, you have the state check, and then you have the reference date. So you could think of for users, you have a user who users who stay on the app, and then you have the state check is are they active or not, and then the reference date is when they signed up. You can also think of like cancer patients. The state check here is that they are still alive or they're not dead. And then in this case, the reference date is going to be their diagnosis date. That's where, you know, like how they have like those different metrics around like 5-year survival and 10-year survival, all those things. Because I remember like one of my relatives got diagnosed with like pancreatic cancer, and that cancer is like really terrible. Like it's like the 5-year survival rate is like 3% or 4% or something like that. It's like essentially a death sentence. because the survivorship analysis is so it has that really it's like one of those gray lines, right, where it's like you just experience that massive decline and like nobody gets out alive because it doesn't flatten out for anybody, and so that could be the case. Other cases you have you can think of like the smokers who remain smoke free after quitting. So you can kind of have maybe the opposite of more of a more positive way of going about it, where you have that's the state check. Are they not smoking? And then my favorite obviously is when I launched this boot camp, I said if y'all attend all of the sessions and you do all the homework, then I will write you a recommendation. And there was a lot of y'all who were like really cocky about that, and you're like, I'm definitely gonna take Zach up on that. And now that you've listened to me talk for like 20 hours, you're like, okay, this is a lot more than I thought it was going to be. But then obviously there's a little J curve there as well. But the thing that's interesting for me is I'm already starting to see that flatten, and I already have a pretty good idea of how many recommendations I'm going to need to write. But that's kind of the perspective that I would think about like these survival analyses is like a state. It's like a state that is prolonged throughout time that is checked versus a reference state. It's the good way to think about it. Okay, so we have one more section here, which is window-based analyses, which won't take quite as long because there's not as much in here as there is in other cases. But so for window-based analyses, you really are going to be the first one here. I love calling is like it's the dads and moms, right? It's like I always think of like mom and dad or the freaking that's the first one where I have day over day, week over week, month over month, and year over year, where you're looking at. I like to think of that as more of like a derivative, right? It's like a rate of change over a period of time, essentially, and that's where using window functions is great. It's so great. And then you have literally the opposite as well. And I love how like window functions do both because then you have rolling sum, which is like the integral, and it's like the accumulation over a certain window. And so you get that as well. And then obviously rank as well. Rank is interesting, but rank doesn't need to be solved with window functions. You can also just use like a plain Jane like order by as well, but it depends on how complicated of a rank you're trying to do. So how does window-based stuff work? So one of the keywords here is rolling, right? You're going to be looking for rolling or week over week, day over day, something like that. And then, but for rolling, you'll see that there's a specific syntax. It's literally this syntax every single time. And then you just change n here. So you change, usually sort here is going to be just, you sort by date. You partition by like, I don't know, user ID, or you partition by whatever the dimensional cut. Maybe you partition by country, or you partition by whatever you're trying to cut by, right? Whatever the grain is. And then the n here is going to give you the number of rolling days, and it's that easy. It straight up is that easy. That's what you do, and like that's how you get your rolling sums. And the cool thing about these is that like essentially they do the opposite of each other. So if you do the derivatives, like the day over day, week over week, month over month, year over year, your line chart is going to get spikier. It's going to get spikier, and it's going to be more sensitive to change, especially day over day. Day over day is going to be really noisy. And then if you do month over month, it becomes less noisy. And then year over year, a little bit less noisy. But year over year is still going to be more noisy than just the regular chart, like the count chart, because that's the nature of it. It's a derivative, right? It's the rate of change of the thing, because now you're relying on two data points. You're relying on what it was today and what it was a year ago. And one of the things that I found always so interesting when I worked at Airbnb is I worked at Airbnb in a very weird time, because normally in big tech they love year over year. Year over year is just it gives the right like acceleration view for a lot of different metrics. But I worked at Airbnb in 2021, and in 2020 Airbnb had a hard time, like because of the pandemic. So we actually, for a while, Airbnb actually changed a lot of their metrics. where instead of looking at year over year, they were like, we're going to do year over 2 year. So they compared 2021 to 2019 instead of comparing it to 2020, because if you compare to 2020, it was just like, we're doing great. We're up 600% or like whatever, right? Because it's like everything was shut down in 2020. So sometimes these metrics can be gamed like that, right? And that's it. That's why those derivative metrics can be so loud and so sensitive. Because if there was a dip or spike a year ago, or a dip or spike today, then you're going to see a dip or spike today, right, for year over year. So it's essentially like you increase the volatility of the chart if you are doing day over day, week over week, month over month, whatever, right? But you can also decrease the volatility of the chart with using this rolling sum and rolling averages. You can, when you integrate, right? And that's how you get a chart that kind of looks like this. So I don't know if y'all have ever traded stocks before. I used to do that a lot. And so you'll see the line here is going to be the ups and downs of the stock price that is normal. And then you see this blue line is actually the 50-day moving average of the stock. So, and you'll see the 50-day moving average is really different, and it's very smooth. And it doesn't it's more of like a trend line than what the actual value of the stock is at that moment in time. And the thing is like you can have an even slower trend line, right? Because you can have a 200-day moving average. And a lot of times in stocks, that's what they look at. They look at the 50-day and the 200-day. And when the 50-day crosses above the 200-day, that's called like a golden cross. And that's like a signal to buy. And then when the 50-day crosses below the 200-day, that's considered a death cross or like a signal to sell. And so you can have like these charts that like, or these trend lines that are based on the actual data, but they kind of remove some of the volatility or some of the day-to-day fluctuations of the charts. And that can be very good. Like that can also be a very good thing because that can help reduce the noise and make the picture a lot clearer of like what's actually going on with this trend. So one of the things about window-based analyses that I want to be just a quick side note is make sure to partition on something. Like if you're using big data, you should probably partition on something because if you don't, like your window is going to be so huge, and then that's going to cause OOM to happen. I've noticed this where like you're going to need to partition on some sort of dimension for the most part, like unless you're just trying to do like the rolling average of like all users or something like that, and it's like that can be like you're going to need to like either crank up your Spark memory or something like that. Like just so a quick little side note about these window-based things in the big data environment that you want to be aware of.
Congrats on getting to the end of the day one lecture. If you're taking this class for credit, make sure to switch to the other tab so that you get credit for it. Excited for you to check out the lab.
First off, we're going to be creating this DDL here. I'll explain how this DDL like kind of works. We're just going to step through this first. So, and we're actually going to be using this same table for their survivor analysis as well. And I think that will be very useful. You'll see here we have users growth accounting, and then we have user ID, obviously. Then we have first active date. So this is the first day that user showed up. This might not this is where cumulative table design can kind of mess up, where like like if you start the accumulation on the wrong day, if you actually don't start at the beginning of history, then you might end up saying a user's first active date is the wrong day and they were actually active much earlier, but like you just didn't start the accumulation then. And that's fine. That's like one of those things that like essentially that goes away over time. And then you have last active date is going to be the last day they were active. And then you have daily active state, weekly active state. So these are going to be our values that are going to be like growth accounting. You remember those like churned, resurrected, those kind of values. And then dates active and date. So dates active is we're keeping this around. This is very similar to, remember in the week 2 when we did the dates active stuff, we're going to be doing a very similar thing in this case. So can go ahead and run that query. That's fine. So what we're going to say here is we're going to say with yesterday as, and then in this case, we're going to say select star from users growth accounting. And then we're going to say where date is equal to, and we're going to start, I want to just start with 2023-02-28. And then, so what we're going to do is we're essentially going to build out growth accounting for the month of March, because that's when I quit my job, and that's like when the data is going to be the most interesting. So when I have to quit my job, launch the company, all that kind of stuff. So then we have today. So we want to start with March 1st. And we're going to be building this off of the events table. So in this case, what we're going to say is we're going to say select from events where there's, yeah, we want to use date trunk here. Date trunk day, then we have event time. And you want to cast this to a timestamp. And then this is equal to date 2023-03-01. And then in here, what we want to do is we want to look at essentially user ID. And then we want to have count one. And this will be grouped by user ID. And this will give us essentially all the users for that day. And we can also have, we can also put like we can maybe group on both of these because we want to have the time. We want this as like today date. So we can have both of those. So what we're going to start with here is this hopefully looks very similar to some of the other cumulative table designs that we were working on before. And you know, yesterday is going to have no data. Or wait, hold up, I need to do a quick delete because my table will actually have data. Let me run this real quick. Okay, so now that's gone and that'll be deleted. So now we have our yesterday and our today, very similar to our cumulative table before. So we can say select star from today T, full outer join yesterday Y. And then in this case, we have, we have our on T.user ID equals Y.user ID. So that makes sense so far. And so what we want to do is we want to do the first thing we want to do, right, is the coalesce here of like, it'll be T.user ID, Y.user ID as user ID. Because we want to get this to match, right? We want to, let me grab this guy again so we can, and then I'm just going to copy, and we're going to comment him out though, so we can just have him for reference. Okay, so we have user ID, and then we have first active date. So in this case, we have two values here, right? So in this case, we have y.first active date and t.today date as first active date. And this is the order of these coalesces matters, and I'm just gonna I think you'll understand what I mean by this. And so okay, so this will make sense. Oh, this is gonna make sense here. So for this first one here, we have first active date. So essentially how it works is if yesterday has a value, great, we're gonna pick that. If not, we're going to pick today's because that means it's a new user and they don't have a first active date that's earlier because they're new. Otherwise, we can pick whatever the one from yesterday was. Last active date is the opposite, where we say, okay, if they were active today, then that means that's the latest date that they were active. And if they're not active today, if today is null, then we want to pick whatever it was the last time they were active. So you see how like the ordering of the coalesce here makes a big difference. Then we have daily active state. Okay, so this is going to be a case when statement. I'm just going to essentially we're going to put this as daily active state, and and then we're going to have weekly active state as well, right? Weekly active state. I'm just going to put some case ones in here. I want to finish out the rest of this stuff real quick. So this date's active. I'm just going to pull from the query real quick because like that doesn't matter that much because we did that last time. That's going to be, I'm just going to grab both of these real quick and just kind of copy these from the query below from, okay, so this is essentially just going to build out that array of dates. and then this is going to essentially give us the dates that we're looking for. So now this is the meat of the query that I want to go over with y'all, is these case when statements here. So let's talk about the very first case, which is going to be when yesterday is null and today is not null. That is the easiest case. So we're going to say when y.userid is null and t.userid is not null, then new. Because that means that they showed up today, they were active today, but they and they weren't in the data set before. So that one's pretty easy. So they get more complicated as we go on here. So now let's talk about what about if they are resurrected? Then in that case, we need to see that their active date is more than 1 day. Like their last active date has to have a bigger difference than 1 day between today's date and their last active date. So if we say like y.last active date, and then in this case is going to be less than t dot, in this case we're going to say today date minus interval 1 day. So then this is resurrected, because what that means is there was a gap, right? That's going to be, or we have retained as well. So let's put retained in first, because I think retained makes more sense, where we say, okay, if last active date is equal to today date minus 1, then it's retained. And then we have, so we're getting there, right? We have new, we have retained, we have resurrected. So we need churned. Churned is going to be 1, and then we also have stale. Those are going to be the 2 that I think are going to be important here. So churned is going to be, so in that case, we're going to say when t.today date is null. So this is this one's a little bit trickier, because we don't have today date. So because it's null, because there's no daily data for that day. But we have, and then we can say and. So this is going to be his y.lat. We're going to need to look at last active date, and this is going to be is equal to, and then there's actually y dot, but we have y dot date. So y dot date is like the partition date, and not the last active date. So we can use this essentially instead to see like what's going on here. So in this case, we can say, okay, if today is null and the last active date is equal to the date, then this is going to be, what should I say here? This is going to be churn. And then the only other thing that's possible is stale. And then let's make this like an empty string for now. So I'm going to run this query, and it's going to be like very, okay. Oh yeah, we got to cast these. Got to cast this as text, because the types are weird. Okay, there we go. So now we have our user ID, we have our first active date, we have our last active date. Oh well, we have user IDs that are null. Oh great. Let's actually filter those guys out. We can say and user ID is not null. That's like weird. Okay, there we go. So you'll see, okay, you'll see essentially everyone here is going to be daily active, like always. You'll see, like, or the daily active date is going to be new, but that's because we haven't started the accumulation yet. So essentially what this means is we're saying this is the beginning of time, and every user that's active on this day, that's their first day. And some of these users might have been active before, and so that's where, like, when you pick where you start the accumulation matters a lot. But I'm not going to do that, because I don't want to do like 100 or 200, because Tech Creator, I guess my platform, if we wanted to actually do this the right way, we would need to run this starting in 2019, and I would need to run this query like 1,000 times to have it be absolutely perfect. But I'm not going to do that because we have 30 minutes. So we're just going to assume that everyone who started on March 1st, that they are new users, even if they're not actually new. So in this case, we only need one more thing here. All right, we're going to need insert into users growth accounting. So one of the best things about growth accounting, right, is this first statement is easy. It's the same. That one's easy. Okay, so let's go ahead and grab these two. And I think this will also be not too crazy. So for retained, in this case, we essentially, like, it's not an equal to for retained, because essentially what it means is that we want to see if they were active at any point in the last 7 days. So in this case, we essentially want to say if instead of equal to here, we're going to say greater than or equal to. And then instead of today date, we want this to be y.date, right? Because the reason why this needs to be y.date instead of today date is because they might not be active today. And so we want to use y.date, and that will be our comparison value. And then, but this is going to be -7. So this will give us our retained. But the good news is resurrected is going to be, we do use today date for resurrected. So let's actually put this one above because I think that makes more sense. So for resurrected, we have last active date. And then, so that means that they have to have been active. The last time they were active needs to be more than 7 days ago because they needed to have churned. So that means that this one's pretty straightforward, right? So we just say, okay, their last active date was 7 days ago or more. And then that means that they were resurrected. And then it has to be more, this is more than 7 days because this is a strictly less than, right? And then if it wasn't, then they're retained. Then we have the ones that get a little bit more complicated here, right? So then we have churn. Churned is going to be next, right? And because we have the other ones already done here. So in the case of churn, we're going to want to do, okay, so we have when y dot last active date is, okay, this is going to be a less than. Let me think about this because hold up, I have that one. This one, this is where like I spent a little bit of time on this. So let me just grab this. Oh yeah, this is where for that's how it's done. That makes sense. So for churned, you actually have to have why is that like, oh, there's a that's why. Okay. So churned, you actually have this to have the t dot today date is null because you have to have that check because they can't be active today, and then the last time they were active needs to be longer than this many days ago, and then but it needs to be greater than. Wait a minute, I think actually this is not quite right because this is gonna catch this isn't gonna catch stale because it needs to be, okay, the last active date was more than 7 days ago. No, it has to be equal. This is actually this is an equal sign, right? Because that means it has to be exactly 7 days ago, because that means that they're churning today, and then yeah, that makes sense to me. Right, because that means that like they were and then otherwise they're stale. That's it. This is actually an equal sign here because that's that one moment in time. And so, and then we have an else here, and we have stale. So now this is our weekly active state. Obviously, for the first run, everything is new. So, and the thing that is crazy for weekly active is that for the first 7 days is that wait a minute. Ooh, that's actually another thing we want to be careful about here because resurrected and retained here. Oh, retained does actually have to go above or there needs to be another condition. And the reason for that is because retained and oh wait, no, it doesn't matter because this today date is going to be well, yeah, it actually doesn't matter. Never mind. I thought my date logic there was a little bit off, and the conditions needed to be cascaded away. No, but it's fine. So those actually do not overlap. So I'm pretty sure this is gonna work. So essentially, you see how like you have like this like kind of crazy like date math that you need to do. Um, this is actually not the way that they do it at Facebook. They actually the way they do it is with bitmath. So you know like the date list int and the bit count and all those things where they shift the bits over. If you have the date list for yesterday and the date list for today and how they shifted, you have like what the value is today, and then you have so you have the two date lists, and then you can compare the bits on either side. You could actually get all of these different states a lot easier. That is like the more efficient way to do it. I wanted to show how you can do things a bunch of different ways though, because like that doesn't matter quite as much in these cases. So what we're gonna do is we are going to we're gonna run this and make sure in the code that I gave you guys for churned, this was like a less than. Make sure you change that to an equal. That was a mistake. Okay, so that ran. And so now what we want to do is we want to just essentially change this to move everything up a date. So it's the same sort of thing where you change the two dates and then you run the query again. Okay, so let's just go ahead and query this real quick. So we can say like select star from users growth accounting, where date is equal to date 2023-03-02. We have the second. Okay, so you'll see here. So you see this user here is in this. It makes sense, right? So he's retained because he was active on both days, daily retained. And so let's find there's going to be some users here who are not retained though. Let's say and daily active state equals churned, because there's going to be people who like for daily active, right? There we go. So you'll see like these are people who were just active on the first, but they were not active on the second. But that doesn't mean that they're not weekly active, because they're still weekly active for the next 7 days. And so they're still weekly active, but now they have churned for the daily active. So you'll see how now like we can see these two different ways that these churn. So you'll see daily active, actually the state here will change a lot more frequently because it needs to be tested essentially on a daily basis. Whereas the weekly one gets tested more on like a weekly basis, so it doesn't change quite as quickly. So like essentially, you're gonna get a lot more retains for the first like 7 days, right, of the weekly state. So let's go ahead and just quickly run this a bunch more times. Actually, I realize I don't need to do that. I can just click the run. Yeah, run the insert into. Then we can do 3 and 4 and 4 and 5 and 5 and 6 and 6 and 7 and then let's do 7 and 8. And then we'll just go do one more. Let's go to the 8th, because the 8th will be where we start to see a drop off on the or we'll do the 9th so that we can guarantee to see a drop off here. Okay, cool. So now we have data all the way through to the 9th. And let's go ahead and look at that. Let's look at the 9th here. So we should see some users who have like dropped off. Okay, there we go. So you see we have some like stale users, and then we have like, oh, look, this guy, he's retained, right? Because he came back, right? Or he's just, this person's like active every single freaking day. That's cool. But you'll see that there are some people who churned here because they were active on the 8th but not on the 9th. So, but well, let's do a little group by here, because maybe, is there a bug? I don't think there's a bug, but it just feels like there's an awful lot of retains there. Oh, it's still just new and retained? Okay, well, I guess there is a bug here. For this is where last active date is greater than or equal to y dot date minus 7 days is retained. That seems right though, because that means that they weren't like, how is it like they are all retained though? Hold up. Because this minus interval, okay, in here we have retained is, it's saying it's y dot active date is, and it's saying it has to be, but this is with today date, but this today date is null. It can be null, and that's fine. Interesting, because okay, so you have the retained and then and the and today date is null. That's how, because I got this to work. I definitely got this to work. This is wild that this is like a little bit off, just a little bit off. That's what, like one of those things about these queries that's like wild is that they can be just slightly off where so because if you subtract 7 from this and then the date is the last active date is greater than or equal to that minus 7. Because okay, hold up. Because if we query this and we just say select star, right, and look at the data here, because we should have like some data here that is a little bit off, right? Because let's see, is first, okay, and then we can say and last active date equals date 2023-0301. So we're just gonna do a little bit of troubleshooting here real quick, see what's going on. So you see, okay, there are users in here that we have that were essentially only active on the first. See, and then this is weird because the why is it getting a hit? Like why is this retained? That doesn't make any sense because this is this would be where last active date is greater than or equal to date minus 7, which would mean that the first is greater than the second, which is, you're saying for here where yeah, because well, like these should all be stale because these are not active on, these have only been active on the first, right? And this is now the 9th, right? This is for the 9th, and that's what I'm saying is that like this y dot date here is the 9th, like that's okay, that's wild. Okay, anyways, there is a bug here that I think what I'm gonna do here, because I want to give time for the rest of the lab here, is there's a small bug on the kind of the way that this is working, because essentially this is saying this is like, because wait a minute, because somehow this condition is being triggered every single time. Like that's so weird. But what I'm gonna do is like I want to put a cap on this, because the whole idea here is I know that the daily active state is working, and that's what matters for the rest of the class, and we can see what's going on. There must be a small bug with these conditions here, but the daily active state is working the way we expect because it's simpler. And the idea here, right, is now you can kind of see, like if we go ahead and we say date and then we say daily active state and we say count 1, and then we can say group by date, weekly and then daily active state. We run this query. You can see okay, we can see when people showed up. You'll see, and when people, okay, so stale is like all the people who like churned out and they never came back. But okay, you'll see on there was 3,000 new users who showed up on the 3rd, right? And it was really hard for me to retain daily active users essentially. So there was 287 people who came back on the 4th, right? And like some people ended up coming back like after churning a little bit, but like for the most part they like are mostly stale now. Anyways, that's kind of the idea for growth accounting here. Now what I want to show y'all is how you can use this with first active state to show y'all how to look at retention analysis for cohorts. So in this case, what I want to do is first we're just going to say select star from users growth accounting, and we're going to say where first active date equals date, and we're going to use 2023-03-01. So we're going to look at this group of users. So you'll see we have a weird number of users. There's like hundreds and hundreds and hundreds of users here that essentially were here. Now what we can do is let's go ahead and look at this over time. So if we look at date and count, you'll see if we group here, group by date, you see how it's always the same? It's always 171, which is like kind of what we would expect. So if we have 100, so this is a cohort of 171 users. That's the total number of users in this cohort. But what we can see is we can say, what if we say count case when daily active state equals, or we can say daily active state in, and we want to say retained, resurrected, or new, then one end. So let's look at this. I think this will kind of give a pretty good idea here. So if we sort on date here, you'll see this is essentially that J curve that I was talking about. So we can, it's not too crazy to build this out, actually, like especially if you already do the growth accounting piece of it. So what we can do, right, is we have our counts, and then let's go ahead and say this is as number active. And then what we want to do is we want to have one more here. Let's do a percent, right? So we have this divided by count one. We got to cast this though, otherwise it's going to give. This is cast. Cast. This is as real. What? Why is it mad? Aggregation calls are not allowed here. Why not? This query looks like that. Like, okay, 1 second. This looks fine to me. Oh, it doesn't like oh, it's because there's I think I missed a. No, that looks right. Count case when cast is real, divide. But you can't divide. Hold it. Will it give it to me this way? Okay. Case when in. Okay, fine. We only care about the percent anyways, so we can move him and we'll just divide here. Because it's probably gonna. Okay, there must have been I must have done something weird, but this looks like it's working. Okay, so now this is gonna work. And you'll see this is, let's say this is percent active. Okay. Okay, so we have our percent active. And then one of the things that's important here, though, is we actually don't, this is working great for one cohort, but this is not that good for, all the cohorts. So what we can do, right, is we want to say date minus first active date as days since sign up, or days since, we'll say days since first active. We'll say that, and you'll see if we do, we got a group on that. So this is going to give us that kind of survivor analysis a little bit. So you'll see, okay, the first day, they are great, right? It's exactly 1. And then as things go on, things get a little bit different. So one of the things that's really cool, though, is now we can actually greatly expand the cohorts here. Because we can actually remove this filter condition. And now this is actually going to give us, okay, so now we have a bunch of users who, some of them, some cohorts are bigger than others because we've had more data, right? And you'll see, but one of the things you'll notice is, it's sort on days since active here. So you'll see days since first active, we have 100% of people, which is exactly what we're expecting. You remember that chart where it's like a curve and it all starts at 100% and then it slowly goes down. And so you'll see that like really we only like these last 2 days we don't want to care about as much because there's not enough data for these 2 days. Or because we need to load more data in because you see the number of users here is not very high, but for these other days we have a lot of users. So you'll see that like okay for first day it looks like it goes 100%, then 5%, and then it kind of stabilizes at about 2%. So it seems like my retention rate for my website is about 2% of people come back, which I don't know. That's like it's probably better now. I mean, this is obviously like 6 months ago, so things have changed quite a bit. But this is the idea behind how to do this, right? And like for example, like let me just show you how powerful this actually is, though, right? So isn't there like there's a way to do this where can we do like there's got to be a way to do like a month, right? Or got to be a way to like so you can add other columns into the table, right? Or like you can group on other dimensions of the cohort or of the users in that cohort so that you can see like, oh, do users who sign up on Wednesday versus Monday or whatever, they have isn't there like date part? Okay, so extract day of week, and then this is going to be from first active date as day of week. And then we group on that as well. And you'll see in this case, this is going to give us a different perspective. So still first day, looking great, right? And then you can kind of see, okay, it looks like well, Wednesday. Looks like Wednesday's looking pretty fire, 13%. But it's also like not enough data in some regards as well. Right. So you can see what day of the week, like you can kind of compare these like day of the week, like, and you can see how this could be like a nice line chart of like, oh, this day of the week is better than that day of the week, and then you can kind of use that to your advantage to like optimize your ad campaigns, stuff like that. So just letting y'all know, I don't think we're gonna have time for the kind of the rolling window function stuff because we only have like 4 or 5 minutes left for today's lab. I was a little bit ambitious on how much content to cover here. I covered a little bit too much in the presentation, but I think that's pretty much it for what I was planning to cover today.
Congrats on getting to the end of the day 1 lab. If you're taking this class for credit, make sure to switch over to the other tab so you can get credit for the day 2